Hello, everybody, and welcome to our first What the Fucking in quite a long time. I can't quite remember when I did this last. Carla, when did we last do this?
July, I think. Yeah.
July. It seems like it was a very, very long summer. So I am joined today by my colleagues, Tim, Teresa, and Carla from Container Solutions. And of course, we're joined by Justin, who is a developer advocate at AWS. Hey, Justin.
Hey, thanks for having me.
It's our pleasure. Now, you're going to get a proper introduction later because you're the main star of the day. But of course, Adrian Moat needs letting in. But of course, we're going to do a little bit of gossip and we're going to do a little bit of a few announcements. And we're going to see how everybody's doing. Are there any regulars on the call or is everybody brand new? Does anybody want to answer that question? I know it's a bit weird answering a question when there's like hundreds of people in the call. It's a pleasure to have you. If you're a return guest, it's a pleasure to have you back. If you're new to the Container Solutions webinars, we swear a lot because, you know, our whole publication and our whole online presence is called What the Fuck is Cloud Native? But even we're sick of the F word. So maybe I'll turn the dial down on the F word this week. First things first, code of conduct. We have a code of conduct that is going to be dropped into the chat box any moment now. Our code of conduct, in summary, asks you to be respectful, be aware of other people, and if you breach the code of conduct, you will be told to stop or you will be removed from the webinar. If you are running online events or conferences and you need a code of conduct for yourself, please feel free to take ours and use it and repurpose it as you need it. Secondly, Carla, what's my second one?
Is the YouTube channel and recording?
Oh, yes, the YouTube channel and recording. Thank you, Teresa. It's been a while. Yes, we are recording this webinar. And in the olden days, I used to say, well, if you've got any objections, please let us know. But nowadays, I say, if you've got any objections to us recording the webinar, you've got to leave. Because we record these webinars and we make the video available on playback or for download. And obviously, people who download content or read the blog can do so in countries where bandwidth is less available than, for example, in the United States or here in Europe. That's about it. So I think nearly everybody is on the webinar already. Teresa will be sharing links in the chat box along the way. So any related content, she will drop it right there. I'm okay if people ask questions immediately or if they've got any clarifications. Alternatively, you can save them for the end and we'll take it from there. Okay, so today we're going to be talking about application infrastructure, but before we get to that, we're going to do a bit of housekeeping, which I've already done. Then we're going to do some announcements, what's coming up in the world of cloud native, what's coming up from the team at Container Solutions, and then our favorite topic. Everybody loves this topic. What the fuck is the gossip? And to take care of the gossip, I will be joined today by our chief scientist, Adrian Moat. Are you here, Adrian?
I am.
Well,
am I the only one doing the goss?
No, Tim's helping you. Don't worry. Don't worry. I saw the panic look on his face. No. So the gossip will be done by yourself and Tim. I'm going to come to him in a minute. How are you? Because you've been on holiday.
Yeah, I'm good. Yeah, I just stayed at home. So.
Well, it was better than working for sure. Okay, so welcome back, Adrian. It's good to see you. For those of you who don't know Adrian and myself, we've known each other for a very long time. And I was just watching the podcast from Dan over at KubeCon, and Adrian, you feature in that. So well done.
I do.
You do, yeah, because I was slagging you off.
Okay.
And Tim, welcome, Tim. Your first webinar, I think.
Well, first as a Container Solutions person, but I did join previous ones.
Well, of course, I meant your first as a Container Solutions engineer, because the others don't. I mean, you're in the big leagues now.
Yeah, obviously. And one of the reasons why I joined, because of these webinars.
Brilliant. It's brilliant to have you in the company, of course, Tim. So for those who are interested, Tim's a senior engineer. Any customers on the line, you can ask him questions. He might be able to help you. But for the time being, he's going to be helping with the gossip section and giving us updates on that. And then finally, we're going to get into what the F is application native infrastructure with Justin. I've got lots of questions that people have submitted in advance. I'll keep hold of them. and when appropriate, I'll bring them to Justin's attention. Right then. Oh yes, right, announcements. If you want to subscribe to the newsletter, you can do so here. We're the coolest people in the world, because if you don't want to hear from us, you don't have to. You don't have to get advertisements. You don't need to hear about our events. You can click whatever it is that you're interested in hearing about. Services, job opportunities, etc., etc. We're the least spammy company I know. If we do spam you, send me an email and we will rectify that. We listen to all feedback. You can sign up there. It is some of the best content about cloud native in the world. Yeah, I guess so. So you can do that right there. We have got an awesome conference coming up. Our conferences are always a lot of fun. Our speakers, most of them are famous, some of them are new to public speaking, often make big announcements, often they get dressed up. The conference is going to be awesome. We absolutely smashed the last conference we did. That was called What the F is SRE. Thousands and thousands of participants across about 6 or 7 different time zones at the same time. This is going to be a doozy on the 4th of November. Please sign up. It's completely free. Share it with your guests. You can't speak because we've closed the call for papers, right, Carla? The CFP is closed, but the event is absolutely going to happen, and we look forward to welcoming people back when it does. And on that note, that is the end of the announcements. Any questions, ask them in chat. And now my favorite part, gossip. What industry gossip? Because the last time we had outages, we had scandals, and I remember it being an extremely interesting series of gossip. So we're going to start with BGP Awareness Month. Who's taking this, guys?
So I'll be taking the first one. And yeah, just as you said, Jamie, hot off the presses, it is BGP Awareness Month. I think within the industry, everybody has learned this acronym nowadays after Facebook's massive outage. It took them a good 6 hours to come back online. And not only Facebook was out, WhatsApp and Instagram was out. And also Facebook engineers couldn't access their buildings. They couldn't physically get into the buildings because Facebook controls the way they access the building. So this was right. A big story.
Now, you've got to be careful now, Tim, because you say everybody is aware of BGP, but I am not aware of that. So I think you need to clarify for some of the audience.
So it's Border Gateway Protocol, which is almost a layer down below DNS, if you want to say. It's what helps DNS broadcast itself. And through a series of events, apparently a command line deleted the connection to the outside world, which basically scrubbed off Facebook from the internet. So they weren't broadcasting themselves to the internet, which is why nobody could access Facebook, even Facebook themselves.
But you know, the great thing was I do a lot of work on WhatsApp, which is part of Facebook, and I had a very peaceful night for the first time in a long time. It was awesome. I remember thinking, wow, everything's fine. Nobody needs me. But then really strangely, because I didn't know about the outage, because I go to bed like quite, on time, because I like to wake up early. So I didn't actually know anything was the matter with Facebook, other than that I wasn't getting any WhatsApps. And then I woke up and I was like, wow, a lot of people woke up today at 5 o'clock to send me messages. And then I was like, that's, I guess people are enthusiastic today, like handfuls of people. And then I realized, oh, there was an outage. And those messages have just been backed up. So that was positive for me.
Yeah, we had a good discussion within Container Solutions about that. We even wrote a blog about it on our website about HugOps and probably the stress levels the engineers were going through during the outage. But yeah, it was a doozy.
That's true. That's true. We got a lot of traction with the HugOps blog. I think we can post that in the chat box. Okay, thank you for that, Tim. Right. Anybody got any sympathy for Facebook? Anybody on the call? A little bit? No?
Well, engineers.
The engineers, yeah, the nice people. Okay, great. Okay, next one. Who's taking this one? Egress from R2 is cheaper than. Where have we gone? Is cheaper than S3. Adrian.
Okay, so
that's Tim again.
Yeah, that's me again. So this is an interesting one. So Cloudflare has announced their object storage compatible S3 service, and they have said that all of the egress will be free coming from R2. I don't know if they specifically decided to name it R2, which is a letter and the number before S3, but interesting tactics there from Cloudflare. So yeah, it's going to be interesting to see how the businesses will change the strategy when it comes to object storage. Are they going to decide to put object storage within Cloudflare and still use AWS's other services, or keep everything into one? I think the big companies, the ones where their egress costs might be in the hundreds of thousands, might consider that. So yeah, Cloudflare becoming a big player on the scene.
Very cool. You heard it here first, folks. Okay, finally, what's happening at Twitch? What is Twitch? I'm so old. Is Twitch like Instagram?
Not quite. Actually, I would like to just mention the R2 stuff, because I think that's really exciting as well. But they're really clever at the way they do it, and you can sort of move on demand. So R2 replicates S3 API. So basically, you can just switch to R2 and point it at your S3 stuff, and it'll just slowly migrate over time. So yeah, they've been really pretty smart about how they've done it. Anyway, Twitch. So Twitch is a streaming platform. It was originally for gamers to, like, you know, broadcast and playing games and chat with people. But it's I'm being laughed at, I think, for being old. Yeah, but now it kind of evolved a bit more, and there's a bunch of other stuff you can watch people programming and stuff on it. It's really kind of pretty interesting platform. But there was a huge hack, supposedly in retaliation for them not helping people put in controls to stop, what was it, hate raids. There you go. There's a term you've probably never heard of, a hate raid. Anyway, the hackers basically got access to all Twitch's data and source code. They've released the source code, full Git repos of everything going back to when it started. But there's a couple of interesting things they also released. They also released payouts for the streamers. So you can now see, like, some of the people that are streaming, like the gamers and so on, are making a lot of money. I mean, only at the high end. But yeah, some of the people at the high end are making millions. It's impressive. But another thing that was there was an unreleased clone of Steam. So Steam, as you may not know, Jamie, is basically where you can go and buy games, like the Xbox store or something, but it's not the Xbox store. So that's probably a bad analogy. Anyway, it was really interesting stuff. Only serious takeaway is if you do have a Twitch login, they have reset everybody's stream keys, but do go and it's probably worth changing your password and enabling 2FA if you haven't done so already.
I love the gossip section. And what is the fallout for Twitch?
So I don't think it's going to be too bad. Yeah, I mean, Amazon own Twitch now. And apparently they've banned all employees from talking about it and stuff. Well, I shouldn't be saying this. We've got people from Amazon.
I mean,
you don't like to talk.
I'll chime in and say that we have a Twitch show called Containers on the Couch. We stream on the AWS channel. We've been doing it for a long time now, and I was never told to, I'm not allowed to talk about Twitch. Okay. I'm not going to, because I don't know any details about it outside of what I've read. So like, there's nothing I can say. But as an Amazon employee, I was not like banned from saying anything. I just know when to keep my mouth shut, because nothing I say has value. So
I mean,
well, I don't know when to keep my mouth shut. I don't think there's gonna be much fallout though, because it's quite a well-loved platform, and nothing's really changed. Does it really matter that people have the source code? I don't think so. No,
probably not. What can you do with it? I mean, I try to ban things like container solutions all the time, but nobody listens to me. So I need to work out how that works. Okay, that was brilliant. I love the gossip section. So for everybody on the call, we are done with the introductions now. Container solutions is kind of a cool place to work. We are hiring. So if you want to come and mess around with Cloud Native and do loads of gossip, you can do so. And then you get to work with people like Adrian. You won't see me very often, once a month in an all hands. But that's enough self-promotion. I promised I wouldn't do too much of that. It's great to have everybody back. The summer was long. The COVID pandemic has been fucking pain in the ass. It's awesome for me to be here. I first spoke to Justin back in the beginning of the summer, and he's been doing some really, really cool work over at Amazon. And we both know Adrian Cockcroft, of course. Adrian is now leading the sustainability group at Amazon, really good friend of Container Solutions, a huge supporter of what we've done. And that's how I met Justin. And he was telling me some really cool stuff when we caught up. And I twisted his arm to come and do a webinar. And after I twisted his arm, I sent him to Carla, and I guess she twisted his arm a bit more, because here he is. So a very warm Container Solutions welcome to Justin Garrison from AWS. Justin, it's over to you.
And I mean, I'll say, like, you didn't have to twist my arm too much. I was interested in the SRE conference you had as a former SRE myself. I attended, I enjoyed the talk. So I thought everything you were doing in that space was great, and I wanted to get involved more. So I was, I signed up for the newsletter then, and I do like the content. I can vouch that I don't remember seeing any spam. So it has been relevant content to me as well. So yeah, happy to come and kind of share what we've been working on. And I am on the EKS team at Amazon. So I help with anything that we're building for EKS, new products. I helped launch App Runner earlier this year, which is kind of like layers on top of containers, and then also EKS Anywhere in August, which was our on-prem using cluster API sort of solution for what we say running EKS in your data center. So that was like what I've been working on mostly this year. But I want to take this time to kind of talk about like what I have seen as the future of sort of this cloud native space and kind of where it's come from, because I can't always assume that everyone has the same experiences. So let's switch over here, and hopefully you see that whiteboard now. I don't like doing slides. If you've ever seen any of the Containers from the Couch shows, I usually have props. I like to teach very visually and interactively. So I don't enjoy stepping through slides. But I wanted to just walk through a story here for everyone's context of like where the application and infrastructure industry has come and where it's kind of headed, that we see in a lot of shifts for just the market in general. So starting, and I'm not a great drawer either, but I enjoy doing it either way. So it doesn't really matter. Hopefully the visual aid is still good. So let's just say this is my developer, and they have this application. And let's go back 15 years, right? Like if you're looking back 15, 20 years, what did it look like to actually, I have a code that I wrote and I want it to run somewhere, and let's pretend it's a web service, because that's what we run now. But 15, 20 years ago, maybe it wasn't a web service, but let's just say for now we have a web service and we want to run it. And for most people, that very first step was like, okay, well, you need a data center. like starting all the way back from like, that's like the actual layer. You need to go buy a building to be able to put computers in. Like no, I have code. I want to run this code somewhere and other people can see it. And it's still the first step. Like, that's just like, well, I'm sorry. Like, this is what life was way back then. So you buy this building and you have to, get power to it, and you have to have cooling to it. And then what do you start doing? You start buying these big racks, right? They're like giant things of metal that always have little like screws that cut your fingers. If you've ever pushed in those screws into racks, like it's a terrible experience. But like, this is what you have to, like, I have code, I want people to see it. And this is, again, you have to start here. And then what you do is you start filling those racks with servers, right? Like there's all these pizza boxes, as we used to call them, to plug in, and literally rack and stack is like what you had to do. Is you put each one of them in a rack, you stack them all up. Some of them are storage, but most of them are just compute. And you're just like, okay, well, now I can run my app, right? And like people can see it. It's like, well, no, like you're almost there. There's like this other piece like around this, which is your network. You need like a network here to like encapsulate all of this stuff, because you're going to have some way that people can get into your data center and like view what's going on. And so now we're close, right? Like we can run the server, we can run our application, and like, well, like actually, like let's plug in all these servers. Oh, we also have like power coming from here that we need to like, and like redundancy, right? Like what's your failure domain? something breaks, like every single one of these servers has 2 power supplies, they have 2 NICs. All of these things are just like, let's keep things running because we're investing so much time in this building that we bought to literally run some code. And it's kind of crazy that like this is like when I look back at it, like my first job was sysadmin, like I racked and stacked boxes, I did this stuff. This isn't even taking into account like all the other layers of like you have an OS, you have to have hard drives, you have to provision storage, like all of these things are like physical. You went and it took days or weeks to get a PO. I need that server to come. Someone has to physically ship it to me. All of this stuff was involved. Like this is what you had to do. So let's like fast forward a little bit in here and like say like, okay, my application is running on a few of these boxes, right? Like most on-prem environments, like you can get an application running. You probably had a team of people do all this stuff, because I don't know anyone that went from I bought the building to I ran the application. That's a pretty big span of like, that's full stack. Like if you bought the deed for the data center and you wrote the code for the application, like that is like for some people that's what you consider full stack. And like let's narrow that down to like actually what a person can actually be an expert in might be a little bit different. But once you have this, again, like failure domains, like this rack goes away, like you have top of rack switches, you have all this stuff to like semi load balance, but a lot of data centers don't actually have load balancers. They kind of do it through, other tricks of just network routes, IP addresses that get shared, DNS, just other ways. Like, like load balancer is like another thing we don't really need to worry about it. So let's just put that there as something we need. And then like you have daemons on these boxes for logging, for some sort of alerting. You have like actual users on these boxes that like SSH in to like do the thing that they needed. They're like, oh, I need access, I need to fix something. That was my experience starting as a sysadmin. We went through this process and developers wrote code, and all they wanted to do was like send me a tar or a jar or something, a war, whatever the actual like packaging of the thing was back then. And they said, here, I need this to run somewhere. And all they wanted was an IP address, or actually what they wanted was a host name. They wanted a DNS entry that said like, I can hit this name that I can tell someone else and it routes to my application. I don't care where it is. Don't tell me the data center. Don't tell me anything else. And like this works for so many people in so many cases, and it's still working today. It's a valid use case for a lot of workloads, and it's a lot of work. This is the opposite of any sort of application native infrastructure, is what we're kind of building towards here, of like, what does it look like when the app also has the infrastructure? And the other limitations here of like, hey, I need my application, I need more applications running, I need to scale it up. What did that actually look like? And in most cases, you're like, okay, well, we're going to buy some more servers and we're going to put them over here and then we'll run your app. But actually, like, what happens when all your server space is full? Or what happens if your like power is at its limit, right? Like that actually literally a conversation I've had multiple times of like, our building can't get any more power from the power company. What do we do now? and so in that case, it's like, well, I got to go build another data center. Like I have to buy another building to scale up my application. Very real concerns for a lot of people. And even, physical space, cooling, all of these things are problems in this sort of situation. So like next wave comes along of, what if all of that stuff was APIs? Like what if it was just software defined everything? And that's where we, come over here, and that's where we have the cloud, right? Like that's what most people think of as the cloud. Lots of different definitions. In this case, we're going to talk about the cloud as infrastructure, whether you want to call it infrastructure as a service, whatever. Like you can do all of the same stuff you had here through software down here. And so I don't really have racks, but I do have, EC2 instances. I get a VPC that encapsulates all of it. I'm replicating everything that I did in my data center because that's familiar to me. I know how that works. And I say, oh, well, guess what? Like my org structure already fits that. We can just have the network admins do the VPCs. We can have the security people, set up security groups. Oh, And like that, it was more important to get people to be able to shift than necessarily the technology. Because in this case, at the end of the day, most of the people that were working on this physical infrastructure weren't actually touching anything physical. They just happened to be a local IP address. And with things like, you have gateways going directly, you have direct connects into AWS. And so in a lot of cases, like these are still local IP addresses. Some people don't even know that they shifted to like a new box. It's just how they manage it. In a lot of cases, these still have users, right? If you're managing the raw EC2 instances and you're saying, well, I'm just going to do everything I did the same, and we're just going to do it on VMs in the cloud instead of either VMs or hardware on-prem. But the cloud did bring some other things that a lot of people maybe didn't have on-prem. There were some things like, like I said before, a lot of places I work didn't actually have a real load balancer. Like that wasn't a thing that I could get internally. We did it through other means, but now I actually had real load balancers in AWS, like virtual, ELBs, ALBs, all these LBs that could now do different things for me. And how I use them really depended on what my application was and all that stuff. But like as a dev, I'm still just like, well, where does my app run? Like, can I run an app on something? It's like, yes, you can. And now we can point a load balancer to it and people can see that with, Route 53, all that stuff. There's a lot of other things that people get confused on, such as, like I mentioned, security groups are, hard to wrap your head around if you're coming from an on-prem environment. There's IAM, right? That's a big one for anyone moving to a cloud environment. There's policies and permissions to all of these APIs, where before in this world, my IAM was probably like a door and a key. That's how I got access to any servers. Is like I actually had a badge in, and that was my IAM essentially. It was like, oh look, I can access the data center, so I can do anything I want. And in the cloud, we really split that up into smaller chunks. Hey, you actually get access to this application or this area of concern. And this is a much more fine-grained environment where how you have access to things. So the cloud really enabled a lot of things, such as infrastructure as code, because now I have APIs and I actually built infrastructure using code, hitting APIs that was all virtual. And I couldn't, to my knowledge, I couldn't buy a data center 20 years ago with software. Like maybe there's someone has a bash script out there that actually buys a building. I don't know. I wouldn't put it past someone, but I didn't know of anything. That's what I would have considered infrastructure as code back then. But the other cool thing about the cloud was once you start hitting some of those scaling limits, you can get more EC2 instances pretty easily. And even when you say like, oh, you know what, I actually want locality for something else, like a new data center is literally a drop down in a web interface. Like I need a new data center. Oh, look, I'm in Frankfurt. Like I bought a building in Frankfurt and now I can deploy all the same stuff. And that's so powerful for people that came from, I need to buy a building situation to now I just need to scale it. And that situation was like, well, let's just fill it out and do the same thing and buy more servers and run more applications. And it works. And the cloud is super powerful at giving that infrastructure to developers who need it. You can more likely be a full stack in the sense of like, I manage the infrastructure through APIs and through infrastructure as code. And I also am responsible for, running that application on top of all those instances in that environment. And that is something that someone actually could do because they offload some of that expertise obviously onto AWS or a cloud provider and say, I just need you to do it. The cloud kind of brought about another situation, some of it running on cloud providers. I like the term cloud distros. It's not really formalized in any way. But these are application specific clouds where this is something that says, hey, if you structure your application a very specific way, I can just automatically do all that other stuff for you. I can just say hey, you can just run that and it works. And in most cases, these are things like Heroku. or even Lambda, where if your app has a certain structure and a certain, characteristics to it, the automation in place can take care of that and like say, hey, this is running now. And that's a great enabler for a lot of people, for a lot of applications that might be, self-contained or might be in a simple-ish environment, or they design their application with these cloud platforms in mind. And they say, hey, I only want to use Heroku. I only want to use Lambda. How do I get my application to fit that mold? And that works really well for a lot of people. One of the things that's not quite intuitive or native is all of these situations. You're like, well, now I need something else. You're like, I actually need a load balancer. I need, DNS. Some cases you'll get it. Some cases you have to like bolt these things on. And in these cases, like let's say storage, which isn't going to fit this box. In these cases, you're bolting on automation. You're not actually like, it's not native to the application. You're just saying, hey, I want my application defined this way. I have a 10-factor app, right? Like that's the big enabler here is we said like, hey, if we make stateless applications, if we build them this very specific way, we made rules around how the application should look that fit very specific infrastructure environments. And that works really, really well with some add-ons. And you say like, oh, application's the same. Now I just have this automation that does the rest of it. And it really is just, plugging into this sort of environment of it builds on top of the cloud and says, hey, all these things are APIs. For certain situations, we'll make that easy for you. And that's, again, a huge enabler. But it doesn't fit everything. Not everything is a 10-factor app. Not everything can fit in these distro environments. And that's where like this next wave of what does infrastructure look like for applications. And that's where I think things like Kubernetes came around. And Kubernetes said, okay, we can take you still want some of those 10-factor apps. Like a 10-factor app runs great on Kubernetes, but we can actually like take a big old hammer and kind of bash some other applications into place and make them fit this a little bit better. And so in a Kubernetes cluster, it added a couple things that weren't really available in some other areas. Like this actually adds an abstraction of a pod or deployments and said like, hey, no, these are first class things. And one of the differences here, which later came to some of these cloud distros too. But one of the things, like if I look at a deployment, let's say I have my deployment for my application. A cool thing you didn't get before was actually like how it upgrades, right? Like versions are built in to deployments. And that's honestly super powerful for so many people. Like that's transformative of just like, wait a minute. This abstraction can be version to version. Sorry, 10. I did say 10, isn't it? It's 12 factors. I didn't want to miss out on. Yes, 12. It's early for me. I'm sorry. It's 9 a.m. So yes, good catch. I can. Let's add 2 to that. Like Kubernetes, right? This is 8-factor apps, right? I'm just kidding. That's not actually a thing. I'm just factor there. That's what the 8 stands for. Not really, but it'd be cool if it did. Someone should make that. What does an 8-factor app for Kubernetes look like? Someone get on that. But in this case, like Kubernetes added some more abstractions on top of, hey, I have code running. It did set similar to these cloud distros. It set a minimum bar of, hey, guess what? You need first. Now my pen stopped working. You need a container. You need to put your application. This round thing now has to fit in this box, this application container. So the application does fit something, but then Kubernetes can come in and actually like use that container as, because it's this universal thing, and it can shape it a little bit better to fit this environment. But again, for some people, this automatic like deployment, I should label that deploys. This is all most people need for a lot of web applications. There's like, I can live off of a deployment abstraction and say that deployment, just has versions and I can upgrade it, I can roll back, I can scale it. I have a different thing that I'm dealing with, not replicas. I mean, you can deal with replicas, but the deployment is what a lot of developers want. It still has some things here, like I need to bolt on a service, I need to bolt on ingress or load balancer or whatever. Like you still need to expose it some way. You still need like external DNS, right? Like you have an external DNS controller or something. There are things that you're bolting on in YAML that aren't, they still look like this up here, this data center, because that's where just a lot of these things came from. But there are some new abstractions in this case, which are really cool to be able to deal with. This also, because Kubernetes was able to gain so much traction, standardized a lot of the application practices, where before, you know, you could build to Heroku and that was all well and good, but Kubernetes came in and said like, hey, everyone, like if you just make a health endpoint, like we can do a lot with that. We can actually like verify and do a lot of things just by default, and that's available to you. You don't have to run extra information or infrastructure to be able to hit a health endpoint. Metrics, ready, these sorts of things are becoming standard in this environment where we say, hey, my application borrows some things from these 12-factor apps and now looks kind of similar. But again, the power, I think, of Kubernetes really came about. We're saying like, this is portable now. I can do this anywhere. This isn't a, how do I do this in Heroku or how do I do this in Lambda? This is, how do I get that Kate's thing into my environment? And that was super powerful. On top of that, we have, these containers, these applications, these pods, I guess. I mean, like, I don't know. I'll just go with pods that get shaped into things that maybe we couldn't run before, right? There's some crazy applications that run in Kubernetes and pods that would have never been possible in Heroku and Lambda and something else that was application centric and said like, hey, mold your application. I've done some bad things in pods that I'm not very proud of, but it worked really well because we have things like mutating webhooks that like when it comes in, it's like, oh, well, you know what? Like I see your application, so I'm going to bolt on this sidecar here that gives me the logging. Like things we used to do at the actual OS layer and say like, oh, I need a logging agent. I need something else added to this. Like we just start bolting on all these like sidecars. We're like, well, my application actually doesn't need to know about them. My application just thinks, oh, well, I'm just running. And I have new capabilities that I can do because inside of this Kubernetes environment, there are standards that we get, even things like service accounts get bolt on by default, which are kind of like, inside of Kubernetes, that's our IAM that we had before. Like we had to go manually define the thing, come back and do the thing. And now Kubernetes is like, well, no, you get a service account. What your service account can do is up to your admins, is up to the application. But it's starting to like narrow down some of these things to be more native to the application itself. And even things like, RBAC is also part of service accounts, but storage, right? I can get, not going to fit it again. Storage, these are bolted on by default. I don't necessarily have to like go fully define something else. I can say I need a volume and it comes from this thing. And that can be someone else's responsibility. And storage, or like a controller, this auto provisioner can say, oh, he needs storage or they need storage. This application needs that storage. Boop, there you go. It's just in place. Like you said, I wanted a mount at this point, go. And you have to think about it. Another group, another controller, something else could manage that piece for you. And Kubernetes does that for more applications now. It's not just these cloud specific things. It's not just these application specific environments. I can get more of that, but there's still things that I do need to define. When I say I need a load balancer, like we set up here, a service, a load balancer, DNS, like those are all still things that like, oh, well, it's still an add-on. I see that we're moving more and more towards a new abstraction on top of what we have here with deployments and some bolt-ons. And I even see it in things like we launched, I was on the team that launched App Runner this year. In App Runner, give me your container and I will give you DNS. Like that was literally like the goal there was like, well, if you just have a container, I can handle scaling, I can handle, you know, your load balancer, I can handle DNS entries. And like that was the bar of moving from this container just straight to like a web page. Like, hey, I just want to access it. It works great in a lot of cases. There's other solutions that do this exact thing of like container now becomes this universal thing. And even inside of those environments, like it might be running on Kubernetes, it might be doing some of this stuff for you. Inside of a cloud environment, it's probably giving you IAM, it's doing, you know, some temporary storage at least. All of that is there, and you can do that in a simple situation. There's still this problem though. What happens when you need to scale your Kubernetes? Like I run out of whatever reason in this Kubernetes instance, or I want to run it in a different location. I need it in, you know, I want to put Kubernetes in Frankfurt. Like how do I do that? And the solution right now is still Kubernetes runs inside of this context of a cloud environment, of a data center, of infrastructure somewhere. So like you still at that point you're just like, well, let's spin up another Kubernetes cluster, and then we go create all of that somewhere else. And it works. It's a solution a lot of people are using right now. It is very valid. There's a lot of effort in multi-cluster support, because now you want to manage applications that span clusters. Now you want to have common tooling and just consistency across clusters. The Kubernetes cluster is the new server, right? Like all of these servers way up here, like how we manage these was with config management. We, you know, like just like clone them out and say like, oh, I just need another one. We had some automation that did some of that for us.
So we've got a question coming in, Justin, that's worth asking right now. Is App Runner the AWS answer to Google's Cloud Run?
Yep, they're absolutely very similar. Like that's the goal of both cases. Of you bring a container, you don't worry about a cluster scheduler, you don't worry about scaling. You know, technically it's slightly different than the Lambda situation, where Lambda has a very similar goal of like you bring a zip or a container and we'll run that per request. In Cloud Run and App Runner, you actually just share the container. So depending on how often that's requested, how many requests you get a second, that scaling can be done for you automatically. And so if you never use App Runner, we actually have App Runner launch support in ECR public. So like I have a demo app, you can literally click a button and you'll get it deployed. I think it's 2 extra clicks to say yes, and then launch it. So like you don't even have to like open a terminal, you don't have to write any code. But that's for a lot of internal teams, like they want like that sort of almost app store style, like, hey, just like, let me run this thing. I have my code somewhere, and you can push that into somewhere and just say like, yeah, it's running now. And I didn't have to create a VPC. I had to pick maybe a region of where that's running.
Cool. I hope that answers the question, Bart. Does that answer your question, Bart? Pretty definitive answer.
Cool.
Cool. Right.
So Kubernetes, again, we're dealing with now multiple Kubernetes clusters, because we still want this. My application developer still says, well, like I want my code to run, and they want it available. And as the internet shrinks the world, in my opinion, like it's so available everywhere, and more people are still coming online. But now we're finding all the physics limitations of like latency as a thing. And like the speed of light can't be conquered in any situation that we've found yet. So like there are limitations to how the internet works. BGP routes can take down, entire websites. So like, how do we get this a little easier for the developer? Because again, the developer wants to write their code. They can be responsible for more things, but they don't always need to be. And now we want to make endpoints that are globally available. When I was working on Disney Plus, like Disney Plus runs a lot of places, and we needed it available because there was a lot of data and a lot of bits to ship around that mattered how fast it could get to people. So we had to replicate a lot of that in multiple places. And doing that in a Kubernetes sense is good, but it's still kind of constrained by these data centers and these regions and availability zones. Actually, that was a big point for like when you moved to the cloud, you automatically got 3 data centers, right? Like they were in a region, but most people only had 1 building, and they said, well, like I don't have 3 co-located buildings or 5 or whatever it is for a region in Amazon. And like now, like in a region, like you just get that. You can say like, oh, I just want this in multiple AZs. Now we want it in multiple regions. And so now we're shifting that from like, hey, it's great to have the redundancy. It's great to have the scalability and less limits around what I can, how big the application can get. And now the problem is like, actually, I need this all over the world. And how do I get there? And that's where I see application native infrastructure. That's the piece that we're kind of building towards. Kubernetes is great. It's getting us there. It added some extra abstractions, and it added a lot of automation and more best practices around some of these things that applications are just getting by default now, where you don't necessarily have, an agent on a box that like always like is actually like looking for a process ID. You have a load balancer hitting a health endpoints and leveling those things up to say, hey, if we want to scale this, we know it has to be distributed. It can't be a single box anymore. It actually needs to be maybe a single cluster, multiple clusters, multiple regions. Kubernetes gets us there for so many things, and that container format is so universal and available to a lot of people that Kubernetes can, again, just like bash that into shape of saying like, hey, you know what, like I'm going to automatically give you those IAM credentials and storage and things that you need. But where I actually see app native infrastructure going, and Kubernetes and cloud are, and even Heroku are very much cloud native infrastructure, where the cloud existed and they built on top of that. And they said, we can do anything with the infrastructure with these APIs. And I really hope and see some of this, what I call application native infrastructure, is becoming like everything is just defined in the application itself, by more of an abstraction and less of a bolt-on process. And so as I write my application in the application code itself, like if I say like read from disk, the infrastructure is going to see that. Like it actually can read, hey, you're reading from disk. Here you go. Here's a volume. Like I didn't have to define anything. I didn't bolt on more Terraform or YAML to say like, oh, like I need this, it needs to be this location or whatever. Things like I just said, read this file from disk. Disk will be there. We can actually look at the behavior of the applications and understand what they're doing in a lot of cases. And the availability of this isn't region to region to region, and then like, oh, I need my database that's over here. It's like, no, we actually have global databases too. We can actually take the same database and it's available in all the regions, and there can be, a global way to deploy an application, or you don't even think about a region. You just say like, I want this application to run. How does it scale? Where does it run? Make it local to my users. Give me an endpoint in DNS. DNS is global for a reason, right? DNS exists everywhere. You can have bad things. You have split horizon DNS. You can do some things that like change how DNS looks depending on where you are. But the infrastructure of the internet for DNS is global. And that is very important for a lot of people, just to say like, oh, I don't know, where is Amazon.com? I don't know when you run that Amazon.com, like DNS looks it up locally for you. It might have, localized IP addresses, all this stuff just happens for you magically. And that works for users now, but it doesn't work for developers. And developers, we're still sort of chasing this, like expanding our scope of what a machine looks like to now being distributed machines, to now being regions. And I do think in the next 3 to 5 years, there's going to be some fairly easy solutions to say like, actually, just make it everywhere. And even things like circadian rhythm for people as they sleep, like your scale can follow the sun if your application is used at certain times. I mean, look at how Netflix has had studies for years and years and years about like how they can scale up and down depending on where in the world people are accessing their infrastructure. And being able to follow that like is something that they had to study and build and train, and they got that stuff to work so that they could save money and bandwidth and, you know, anything they can backfill some of that like empty space with like, you know, machine learning jobs, other things. And I do think that in a lot of cases, like this application native infrastructure is going to be able to do some of that for you. One of the other things that we haven't talked about is a lot of these situations for these cloud distros are great for very simple applications, right? If I have one container, or I have a Jamstack website that I can run that a lot of places, and that's actually pretty easy. There's not really like a complaint about that right now. If I'm an individual developer, I'm like, oh yeah, I've hosted things on Amplify and Netlify and GitHub Pages. Like I didn't think about like where those ran or how they were scaled. It was static. Like it was fine. I didn't have to like talk to other things. If you've ever worked at a larger business or an enterprise, like that environment is not a bunch of individual applications. Those are very tightly interconnected. You know, microservices has been a trend for so long, and microservices aren't decoupled. Like they are it's the monolith on multiple machines, and it's very tightly coupled. And so in some cases, like this simplistic view of an application isn't reality for so many people. And you can do this today if you have an app. But this application native infrastructure, the other thing I think it's going to provide to us is native application to application permissions and boundaries, where I can actually, I don't have to define like IAM or VPC peering. My network boundary becomes the application. We see this now with service meshes. Right? If you're running a service mesh, you can define a lot in that situation of like, hey, my app has a sidecar proxy, everything goes through the proxy, and I can control that centrally. And we're getting there with other things too, where, you know, if this application wants to talk here and it's not allowed, like I can deny that at a lower boundary, and I don't need to set up VPCs or security groups or subnets. I can do that app to app in the same cluster right now with Kubernetes, but eventually we're going to get there with app to app across regions and across accounts, where you don't actually have to worry about any of those situations of like, oh, I need someone to set up that peering situation. I need those routes. I need these other things to exist. It would be great. And hopefully, like, I see this as a trend. These abstractions are coming that allow us just to say like, actually, just let the application talk to that application, and you have centralized rules. But how it actually made it there, how the network, like where's the layer 2 switches, all that stuff is just taken care of for you. And that's where I actually see a lot more power for, again, the eventual, you know, developer here says, I want this to run, and it's not an easy environment anymore. It's getting more and more complex. This isn't like single applications. Like this problem has been solved for single applications. Application native infrastructure long-term for more and more environments, similar to what Kubernetes did with applications and said, hey, a couple best practices and we can bash these things into place. We're getting there with this application native infrastructure to allow just more things powered by the application itself. Question from Bar is would the integration services go as far as what an API gateway does, or would be abstracted away? And I think it's a new abstraction. I don't think that telling applications what type of load balancer you want is long-term the best situation. Like when you run Envoy proxy or something as a sidecar, you don't actually think if it's Envoy or not. Like I can choose Linkerd, I can choose Istio. It doesn't actually matter which proxy it is or which load balancer, client-side load balancer I have. What matters is the rules and the capabilities. And that's where VPCs are headed. And that's where things like lower level network is just like, hey, you know what? Let's look at this application first and see what it needs to communicate to. And we can add our policies and our rules around the application and not worry about which machine it was on, which metadata endpoint it got access to, which IAM credentials it has. We will have some sort of form of credentials and identity for the applications, because that's how we can verify all of this. But it's not going to be the same situation of, oh, well, go set up that other account, go set up that other thing first. It's like, no, you deploy your app, I'm going to deploy my app. Let's let them talk together. I don't care where they were. I don't care how they scaled, anything like that. I think, again, that's where we're headed as an industry. It's where we're headed for what we need to do as this infrastructure gets more complex. And Kubernetes isn't designed to scale globally. Like, you don't have one cluster that goes everywhere. There are lots of tools and things that are trying to make that easier to manage multiple clusters, but it's still not a new abstraction. It's Kubernetes fundamentals. It's native things inside of Kubernetes to say like, oh, well, actually that node is a cluster. So we can hide some of that stuff in the existing abstractions. But what Kubernetes did, again, that I think was great, was added those abstractions directly into the APIs. And I could see us getting to that point of a new layer of APIs that become standard, whether that's from Kubernetes and open source, whether that's from cloud providers directly. Somewhere in there, we're going to get a new layer that actually makes more complex environments possible. And that's what we're missing in a lot of cases, is simple solved and complex is complex. And the last thing, like what you get out of this sort of environment of developers just building my application, you get all of the like observability, you get all of the like access debuggability that you wanted from the application. And right now that's typically at that infrastructure layer. That's a sidecar. You might have, an APM or something in the app itself, which does help because you can gather that information and ship it somewhere, and then you can kind of triage some of that. But as the infrastructure collapses around the application, the feedback loops become faster for a developer. I see Robert asked a question, great question about being on the ops side of the house, having the platform ready for cloud native developers, plus being financial services with a lot of regulation, makes it hard to figure out the balance between developer usability and complying to the rules and regulations. Thoughts on that? Absolutely. Rules and regulations are very slow to catch up to technology. Any environment that is regulated is going to be slower and is not going to take advantage of some of these things immediately. If you have certifications you need for, SOC compliance or whatever it is in your environment, that's if you're taking credit card payments, those situations, it's going to be slower to adopt these things. The future is already here, just not evenly distributed, right? Like that's even more so in areas that are regulated highly, and especially also in government. You're taking, tax money and you're building things with it, and that needs to be audited and regulated. Because if I was working in government, I can't just go spend $1 million and just say like, oh, well, like I needed Kubernetes. Like, wait. Like that's actually someone gave you that money. Like we need to be able to prove where that money went. It's different inside of startups, inside of companies that don't have some of that regulation and the audit, requirements. But absolutely, like in those sides, in that on the ops side, some people are scared about like, what does this mean? What does this application native infrastructure mean for an ops person? And I would say it's the same situation when you move from data center to cloud. I had so many people in ops that were like, I manage that box, and like, that's my box. What does it mean when that box is virtual? And it's like, actually, you become more valuable to your company because as you shifted here to using infrastructure as code, you could do more things. As you shifted here to doing 12-factor apps and cloud distros, your value became much more aligned with where the business was making money and not as much of an overhead. Kubernetes is kind of a mixed bag of, you can get more applications into this environment, which is valuable to the company because you can reduce some of those concerns around, oh, that box was a snowflake, or, like I had to take me 3 days to go set up a server for a very specific application. Kubernetes, let's just make the applications generic and then they can all run here. So as a Kubernetes is back to kind of a cost center, but it allows more things to be part of that cost center. So your scope grows of what you can do. Down here, ops people that are used to SSHing the servers, managing the stuff, there is absolutely still a need. Your skills have to evolve over time, right? You're not racking and stacking boxes. You don't deal with the little screws that you push in and cut your fingers. That's good for you. It's good for the business. I don't know what exactly the ops role is here, but I know there'll be a place for ops people that have a mindset of, how do I globally scale these things? How do I make sure that availability is there? And this isn't everything. This, again, we're probably going to go back to a more centric, non-generic situation with application native infrastructure first, where we're going to solve the problem for the 12-factor apps again, or the Kubernetes native apps first. And then we're going to expand that and say, okay, now we're going to batch those applications into more of this infrastructure to make it fit again. And it kind of just goes back and forth around how it looks for the application developer and how it looks for the infrastructure. And so first I see, again, your stateless or temporary, temporary writing applications getting a lot of benefit from this. And as that will grow, we'll get more things like machine learning jobs, or like, I need a GPU. That'll be defined in your application. The infrastructure will see that and say, oh, cool, here you go, here's your GPU. I need, storage, I need whatever access you need to a database. Like, the infrastructure will be able to see some of those requests, and it'll be defined in a more high level abstraction. But absolutely, like, ops people, like, please don't like push against this. It has not proven very good in the past of moving to cloud or moving to Kubernetes, and embracing some of it and learning how it works, and also becoming, I guess, realizing more and more that you've been a developer for a long time. You just don't have the title. I see that for a lot of people in security. I see it in operations. I see it for analysts. They don't think they're doing development work, but really they just never had the title. And a lot of the stuff they do, they run commands, they get data, they process data, and they send that data out. Sometimes your APIs are people, where you're talking to people instead of something in code. But absolutely, like, lean into that and know that, like, anyone that's working on infrastructure and applications and technology, I think, should be considered a developer or an engineer at the very least, and understand where they can fit in these new worlds, because it constantly changes. And that's where I like to push people to say, like, you are part of this. Let's just figure out what you're passionate about and what you want to do, and there'll be space.
So, Justin, we had a few questions submitted to the webinar before they kicked off as part of the registration process. Are you ready to take them now?
Yeah.
Right. So this is quite a good one, I think. This is from Jared Clark. I'm not sure if Jared is on the call now. The question is, how do you expose all the added functionality without scaring away the developers? So in Jared's case, they've slowly exposed networking, authentication, secrets management, etc., but only a few of the developers are willing to learn. So most do not want to follow a you build it, you own it approach. Do you think that's down to company culture? And how can you resolve that if 90% are not at all interested?
That's that comparison here.
I'm going to copy and paste that into the chat box.
Cool. I think that's a lot of comparison here between how these cloud distros or applications that fit the environments were programmed, where they didn't have to learn all of those things, but it wasn't very flexible in every situation. And so as you want more flexibility, you expose more things. Not every developer wants everything. Like, that's not, like, you don't have a Kubernetes application that uses every feature of Kubernetes. You have an application that uses very specific things, and you just have a lot of applications that use specific things. Carving that out for a developer is very difficult to say, oh, this developer only cares about storage. This developer only cares about load balance services. Whatever the case may be, the more customers you get, they're going to use all the features. That's why Kubernetes has grown to have so many features, because more and more applications go into this space. In your environment, there's a heavy trend for a lot of people to, a lot of organizations to have productivity engineering, something that reduces the cognitive overhead for developers and says, hey, we can make the thing you're working on, we can make it more native to what you're doing. Don't try to do that for everyone and everything. The productivity engineering will fail if they try to be everything to everyone. You really have to find what your applications are and what the maybe 70% use case is. find the 70%, 80% use case and optimize for that, because there's always going to be things outside of that. You can't give everyone every knob and then hide every knob. Like, it's just, those two things are completely, in direct conflict with each other. And so finding the use cases of saying, hey, actually, like 60% of our workloads are load balancers. Cool. We can just add a load balancer to everyone. If you make a deployment, you can add a controller or something and say, hey, guess what? You get a load balancer, whether you like it or not. And being able to like give that by default to some people and in the ways that people use them is important, because some people want like subdomains, some people are going to want like slash routes. Some people, there's all these like situations, like everyone's like, oh, I need this feature. You're going to have to all of those things expand. So find the least common denominator first, and then figure out what the next 60 or 70% of use cases are and solve that problem. If you just start adding every bell and whistle, you're not going to be able to pull those things back, because someone's going to depend on them. And that's actually the hardest part. Kubernetes early on, it wasn't about what it could be or what it was about what it wasn't, was the hardest thing to determine and say, like, where's the boundary of Kubernetes doesn't do that. Kubernetes could do everything. It absolutely could just like keep adding every feature. It's like, oh, if someone wants this, we got to add it. One of the best things we did in a previous job was we did not allow stateful storage in our container clusters. So if you have stateful applications that need to write to disk and that information is important, we can't solve your problem right now.
Yeah,
that was a small use case for our developers, very vocal, and they said, they absolutely like, we can't do this without this local disk state. But we didn't have the time or the bandwidth to solve that problem. And so we said, actually, you know what, like the other 70% of people, we need to solve their problem first. A lot of people then said, hey, you know what, like maybe I don't need that disk space. They rewrote some things and made it possible so that they could run in those environments. Not having local disk state solved us so many problems in the long term, where we could migrate people way easier. We're like, hey, you know what, CVE came out, we can just push that patch, and no one really cared because we didn't have any state on any of the applications. Yeah. Some of those decisions we made early on were super powerful for us by saying, like, we can't do that for you. It's going to be hard early on because you're going to get the abstraction wrong in Kubernetes. If you give someone kube control and say like, no, don't use kube control, use this other abstraction we made, you're going to get it wrong. I'm sorry. Like, it's just, no one gets a perfect abstraction right the first time. So just solving like a smaller problem is a lot easier to say, this is the abstraction we can solve for this thing. Everyone else you can do kube control for now, but you have to give them value to come to your abstraction. And you can't just say like, oh, I can't do all those things for you, rewrite your app and then come here. It's like, that's not going to work. So you have to actually say like, hey, if you come over to this abstraction, you get X, Y, and Z for free. You don't have to do the observability piece. You don't have to do whatever other things that they have to do. So solve their problems and focus on what their problems are. And then you'll get people to migrate if it's valuable. If you're not getting people to migrate, maybe reevaluate what you built.
Yeah, absolutely. Okay, we've got a good question here, Justin. For most developers, or for tons of developers, it takes a lot of effort to shift their code from localhost into a container. Does AppRunner have a vision for developers to be able to write code and build within a container?
There's a lot of tools to help you write code within the container. AppRunner actually takes, similar to the cloud distro Heroku, like you can bring code, and if your code is shaped a certain way, it'll build the container for you. It's just like Heroku, just like these other platforms. And you say, hey, I structure my application this way. I have a specific name file. AppRunner you can tell AppRunner, didn't the power go out for you? This is amazing. Your internet's still up, but the lights are out. All right, I'm sorry. For AppRunner specifically, we do build a container for people. And so we say, hey, like write your software anywhere. And it pushes, once you push to GitHub, you can trigger that container build directly within AppRunner. And you don't have to worry about build infrastructure. If your application is built a certain way, it'll build that container and deploy it for you. Again, lots of people in between there typically are, like DevOps engineers, Jenkins, engineers, someone doing CI/CD. There's teams and infrastructure that does just that. And that is a valuable thing for a lot of developers to say like, hey, we'll take that CI/CD from you. And you can do that now with things like App Runner that'll automatically build and push that. Even GitHub runners or GitHub workflows, GitLab runners, GitHub, they all have these situations where you say like, oh, here's a bit of YAML, here's a tool or something that defines what my application is, and I want you to build that the container for me. Building within the container, I think is just a different story, because it doesn't matter where the files exist on disk, because we still at the end of the day are dealing with files that we shove into this tarball. Building within an application doesn't get you an application, get you a container that runs your app. It's different environment. Your dev environment in a container is different than your run environment in a container. So I love developing like Gitpod and GitHub workspaces. Like, it's really cool to be able to do that development inside this contained space. And it does help with some productivity for a developer to get their workspaces up and consistent across a team. But it's not the same thing as shipping the container into prod. Because your development environment is very different. You don't have VS Code. Hopefully you don't have VS Code in your production running containers.
Okay, cool. So I'm not sure, are there any more questions for Justin? Otherwise, we might start to think about wrapping this webinar up. Especially for you people in Central Europe, this is late. This is like 7:15. Time to go to have your dinners.
And for people that don't have lights on anymore, I mean, that's like...
Yeah, so it's getting dark, right, over here. Winter is definitely coming. Winter is definitely coming. Any more questions for Justin? Well, I think then, team, I think we all are in agreement that we need to give Justin a kind of huge round of applause. I think we're all in agreement, right? What's happened to the Dutch office? Dutchies, why are you sat in the dark?
Because our light is not working.
Wow. Okay, this is not. We've paid the bill, by the way. We've paid the bill. Okay, so any of our customers who are worried about business continuity, the bills have all been paid. Brilliant, Justin. Massive round of applause. It was brilliant to have you on your first What the Fucking Are. How did you find that?
Sorry, we're muted again. This is great. I love the questions. I love like where things are going, and a lot of people's concerns now with like what's next after Kubernetes were absolutely the same concerns before Kubernetes. And you, if you were able to learn the cloud in Kubernetes, you'll learn whatever's next. And I don't think that that's a problem for some people, even if it's scary. And that's where like I try to encourage people to like, hey, like don't just sit and say, I'm done. Like we made it to Kubernetes, we're good. So like keep pushing yourself and just, you know, learning new things. And absolutely, like if you could learn these other things in the past, like totally you can get the next one too. So.
And Justin, if people want to follow up with you, where can they find you? What is your Twitter handle?
Yeah, I'm mostly on Twitter, I guess. I'm Rothgar on Twitter, which is an old name. We actually just last night, there's a new Twitter communities which started. So we started a Kubernetes community on Twitter. So if you look for that, it's like a slow roll out of like invite only right now. But it's growing. Even last night, I was the second person in the community, and now there's like 200. So if you want to follow up with just Kubernetes in general, that's gonna be a really cool place. And then I also do regular streams on containersfromthecouch.com, which is a YouTube stream. We do everything sort of cloud and container related, but also like we just like to nerd out about containers in general, low level stuff. So it's a fun show. Again, we try to do it at least weekly, and various container topics. So we have a big stream next week for KubeCon. So if you're coming to KubeCon, I'm going to be there at least Wednesday. So you stop by and say hi.
Very cool. So have a great time at KubeCon. Carla and I both just pasted your Twitter handle into the chat box if people want to follow up with you. Bart is saying, thank you very much, Justin. It's really interesting to see which direction AWS is thinking, especially as one of the biggest retail customers of AWS in the Netherlands, wink, wink. Well, Bart, if you need any help with your AWS cluster, you know who to call. So we have got a lot of people also from Osman, Robert, Max, thank you. So I think, Justin, you've been a hit. You've got some very, very happy listeners tonight. And from the Container Solutions team, thank you very much.
Yeah, thank you. Thanks for having me.
And that, everybody, ladies and gentlemen, is a wrap. So please keep your eye out onto our Twitter feed or onto the newsletter for all of our upcoming events. Don't forget, we do have the Cloud Native Conference coming up on the 4th of November. The team in Amsterdam, they will switch the lights back on. I'm going to transfer some money now to pay the electricity company. It's been a pleasure, a real pleasure to see you all again. And I can't wait for the next one, which I'm sure is going to be in just a few weeks. So until then, thank you and goodbye.